All right, so just one more section, and I do want to talk about for this week. I do want to talk about law of cosines, and then just briefly mention a couple area formulas for triangles. So, really, you've only seen one area formula. There are actually a couple other different ones. I would just like to briefly mention. Okay, so this section is 7.3, law of cosines. And I think I mentioned in the last video that you would use law of cosines if you had a triangle that was side, 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 or side angle, side. So if you don't have two of the angles, would definitely start with this law of cosines. Okay. So what is the law of cosines? So if I have a triangle, and I have that same kind of oblique triangle maybe that I had in the last video, and I have, say, A, B, and a C. I hope that blue marker, I think you can see that. A little a, a little b, a little c. So I have this set up. So I could write down three different equations. Really, it's just one equation. Kind of like on the last one, it's one concept. And that's how I'm going to treat it. But just to give you an idea, you have that c squared is a squared plus b squared. If it's a right triangle, if it's an oblique triangle, there's like this error term at the end. So it's c squared equals a squared plus b squared minus, and then 2ab times the cosine of this angle c. So here it's the side c, little c, and here it's the big C, the angle c. So two different ones. This is a little a, so this is side A, this is side B, this is side A, this is side B. So really the angle is only showing up one time here. And then, of course, I could write it a couple different other ways. Law of cosine, so I could write, b squared is a squared plus c squared minus 2ac cosine of, say, big B. And thirdly, a squared is b squared plus c squared minus 2bc cosine of, can you guess what that one's going to be? Big A? Okay. So like I said, it's really the same concept. Now you can write those down, and if you struggle with what I kind of just a shortcut way of thinking about it, then that's fine. I really think it's almost overcomplicating it if we write those down and use that. As you'll see, I just kind of want to do a couple examples. Hopefully you'll agree with me. All right, so I just want to solve a couple triangles, not do like a million problems. I think I'll give you enough to do this. Sorry if you didn't have those, pause it, go back. But I want to do 13 where it says solve. And I've got this triangle right here. I've got A, and I have 5, 3, 121 degrees, B and C. Solve that triangle, right? So we don't have our little a, right? And we don't have big B and big C. So we'll want to go through and show how we can find all of those. It doesn't really matter which one you start with here. So I'm just going to start by finding the little a. How would I find the side? So you may notice if this was our triangle, like I could say that, what is a squared, right? Well, that would be like 5 squared plus 3 squared. So like our Pythagorean theorem, but then I have minus 2, and then times those two sides, 5 times 3. And then the cosine of the angle between those two sides, which is 121 degrees. And that's the law of cosines. That's really all it is. I can label all that, and you can plug it in to see it's the same. Like I could call this little b, I could call this little c, and I could call this, big A. And you can write down that equation that I had with the a squared earlier, But that's really what it is. And I think that's probably a better way of thinking about it. It's just saying this side squared is this side squared plus this side squared minus 2 times this side times the cosine of the angle between them. Okay? It seems like a lot, but it's really the same pattern every time for law of cosines. Now, what I have on this right-hand side is really a number. So to find little a, I would take the square root of that number, whatever that is, and I'm just going to do that on a calculator. That's the easiest way. And see what we get. Okay? So I'm going to take the square root of that. I would punch it in. Square root of 5 squared plus 3 squared minus 2 times 5 times 3 times the cosine of 121. And I notice I get like 7.0-ish, right? Okay. So I've got one, but I need two other ones. I need those two angles. Now, I would recommend you could actually use law of sines here. It's safer to use law of cosines to find the first angle, especially if this angle is not greater than 90. And I'm not going to elaborate on that too much, but I'm just going to use law of cosines to go through and find the second one, and then we can find what the third one is. So how would I find this angle B? So for that one, I'm going to say that, let's use this law of cosines again, right? So I know that 5 squared is equal to 7 squared plus 3 squared minus 2 times 7 times 3 times the cosine of that angle between 7 and 3, which is B. So I have something like this. Okay, I think I'll show you both ways. I'll show you this way, and then I'll also show you if I use law of sines. So this is finding B here. So that's one way to do it, is to start with law of cosine. So 5 squared is 7 squared plus 3 squared minus 2 times 7 times 3 times the cosine of the angle between the 3 and the 7. So I have that equation. I would go through and simplify all this. So this is 25. This is, say, 49. This is 9. This is, I think it's 42. The idea here is to get cosine of B by itself, and then cosine of B is equal to some number, and then we'll take the cosine inverse of that to get our angle. So that's kind of our strategy, okay? So if I do that, notice this 42 is multiplied with the cosine. So when I combine these, I can combine these numbers here. That's 58 minus 42 cosine of B. Subtract this 58. I think that's going to be negative 33. I hope that's right. Okay, it's equal to negative 42 cosine of B. All right, and then I divide by negative 42. So cosine of B, negative 33 divided by negative 42. That's really just a positive 33 over 42. And then once I'm there, to get B, I would just do the cosine inverse, which we did a little bit of last week, but cosine inverse of this. And I would want to be in degree mode on the calculator. Okay, so degree mode, and do cosine inverse of, say, 33 over 42. And that would get our angle in degrees. That's 38.2 degrees, as you see there. Okay. Now, let's go through and use the sign and then talk about which one of those would be, better. Let me write this and we'll do the other method and see which one's closer. Talk about which one would be better in this one. Okay. So the other way I can do it is to go through and use law of sines to find big B. Okay, so if I was going to use that, I could do, say, sine of B over 5 is equal to sine of 121 over our newly found 7. And I would then want to go through and find B. So what I would have to do is isolate the sine of B and then take the sine inverse of that. So what I'd want to do is multiply by 5. Let's see, this 5 here is going to cancel. So I get sine of B is 5 times the sine of 121 over 7. And that's going to be some number. If I put that on a calculator, I get something like this. Sine of B was like 0.61226. And then I want to take the sine inverse to get B. So B is, say, the sine inverse of that. So sine inverse of 0.61226. 37.8. Okay. So it's interesting that we don't get the exact same, and that's due to kind of some rounding because we didn't find this side exactly. Okay. We actually rounded it when I did that first step. If I had carried out more decimal places, both these answers would have been a little bit more accurate than they are. The answer should be 37.6 degrees. Okay, so in each one of these cases, we're actually a little bit off because of how we rounded this side. So especially when you're going through and doing some of those Alex problems, the more decimal places that you can carry through on these calculations, the better, okay? Because you might get some of these rounding errors, okay? And I'm going to give you, unlimited attempts for the homework. So you go through and kind of figure out exactly how many decimal places you need to carry through to get the answer. For this one, let's just say that we use the 37.8 and we use the law of sines. You may notice that this here gave an output of 37.8. Remember the sine inverse, the range was between negative pi over 2 and pi over 2. In degrees, that's between negative 90 degrees and 90 degrees. So this sine inverse is never going to return an obtuse angle, one that's bigger than 90. So what I was mentioning earlier is be careful if you're using it to go through and find an angle, especially if you don't know whether or not the triangle is obtuse or not. Okay. And once we have that B, a good value for it, finding C is not difficult. So I can just take 180 and subtract those two. $21.2. Okay, and that would be it. Okay, 15. So I want to do one where, actually let's do 16. Let's do one where we have all different sides. Okay, so I don't have any of the three angles. You see, I'm missing angle A, I'm missing angle B, I'm missing angle C. It doesn't matter which one I find first. Honestly, if you want, and I think I'll let you verify. This would be a good one to let you verify this on. You could use a law of cosines and kind of safely get all three of these. Let me show how I could start. Maybe I want to find angle C to start with. So I can use the fact that, say, 8 squared is 10 squared plus 4 squared minus minus 2. Remember, we have that 2 times 10 times 4 times the cosine of that angle between the 10 and the 4, which is C. And I can go through and find that angle C. Let me just remind you how we did that on the last one. So I got 64 is 100 plus 16. This is 80. 64 is 116 minus 80 cosine of C. I think negative 52. So negative 80 cosine of C if I subtract the 116. Divide by the negative 80, I get 52 over 80 equals cosine of C, and then I would do the cosine inverse. I'm in degree mode, and that will get my angle C here. Okay, so I would do cosine inverse of 52 divided by 80, 49.5 degrees. Okay. Yeah, that's most accurate. Now I could get the other two very accurately because I don't have to use any of the angles that I'm getting from this computation. So I could use law of cosines to get these other two angles as well. All right, unlike the last one where I necessarily introduced some kind of error when I rounded that 7 to the nearest tenth, and we saw both of our answers were a little bit off, is what I was saying. Okay, so instead of carrying through all those decimals, what you could do is you could find B. Well, how would I find B? Could you tell me an equation to find B, and then I'll have you solve it. So B, I could find it, I could do 10 squared, right? Was 8 squared plus 4 squared minus 2 times 8 times 4 times the cosine of that angle between 8 and 4, which was the B. Okay, so I will have you find that with the method that we just did, okay, on the last one. And then the other equation that you're going to solve would be if I do 4 squared, was 10 squared plus 8 squared minus 2 times 10 times 8 times the cosine of A. So what's B, what's A? I want you to go through and find those. And pause it if you don't want the answers right now, but you should get these to the nearest tenth here. So B should be 108.2 degrees, and big A should be 22.3 degrees. Okay. All right, and I said I was going to mention a couple formulas for areas of triangle really quick. Sorry. It's so cool that you can't not do it. My best, Sean Connery. Okay. Area of a triangle. So the formula that you're familiar with here. You have a triangle. It's right angled. Maybe you have its base and its height. And the question is, what's the area of that triangle? Well, you're told that, okay, it's 1/2 the base times the height. Okay, that's all well and good. That's very limiting. What to do in the situation where maybe I have an oblique triangle where, let me just pick the one we were just working on, the 4, 8, and the 10. What would I do in a situation like that? Well, I don't have a right angle I don't have an altitude drawn in. I could get it actually, okay, by thinking of it, drawing an altitude in and finding some angles and so forth here. Actually, it's doable typically that fashion, but there's actually an easier way to do that. And there's also an easier way to do a triangle like this to find its area when I have, say, 10 and 11 and, say, 40 degrees. Maybe one like that, and I want to know what the area of that triangle is. There's actually an easier way to find the area of this triangle, even though it's not a right triangle either. Okay, so there's some formulas. And again, I think I'll give you a picture, and I don't even, did they give this a name? Okay, yeah, I guess they call it area of triangle. But they call it the SAS formula. So it's got to be like a side angle side case. So if I have a triangle like this, maybe, and I've got A, B, C, like that, and I have this set up where I have little a, or I have little b, and I have little c, just like that. I can actually compute that area of that triangle using any of these three formulas right here. I can use that the area is actually just 1/2 of, say, any of these, take your pick, A times B times the sine of angle C. I can use 1/2, instead of using A, B times the sine of C, I could use B times C times the sine of A. I don't want that to be confusing. This is the area. So that, not the angle A there. So that's the formula for the area of the triangle. And then the area, one last formula, would be that I have 1/2. What's the other formula? A times C times the sine of, say, B. And I have those three formulas right there. Now, it's really, again, the same. It's not a formula in the formula, since it's really just the one concept, right? You multiply, if I have something like a side angle side, I multiply the sides times the sine of the included angle. Let me show you what I mean by going through and computing one area here for you. Actually, in fact, let me do this first, and this might convince you this formula. Let's take this one, okay? So I have this triangle. It's a old way, which still would be fine on this one. That area is 1/2 times the base, which is 3 times the height. And I get 6, okay? What's the new way? Well, the new way would be to say, well, it's like side angle side here, so I would do 1/2 3 times 4 times the sine of the included angle. The included angle between the sides is 90 degrees. What's the sine of 90 degrees? It's 1. I remember a unit circle, so I actually get 6 as well, right? Now, here, it's easier to do the old way, right? But what about if I had one like this, and I said find the area, and let's round this to the nearest tenth, and let's say I had 100 degrees, and this was, say, 5, and this was 7. And let's say they're meters. So what's our area? What's going to be 1/2 times 5 times our 7, and then times the sine of that 100-degree angle. And that's all I would be doing to find the area there. So I'd punch it in. And that's the area. Sorry, I said I was going to use area. Area. Okay, well. Okay, hopefully that's okay. That's the first formula that we have. Let me take a look at the second formula. So this one is a famous formula. It's the only formula that was actually discovered by a bird. So that this formula was discovered kind of in the sand. It had been scrawled by a heron. So it's called Heron's formula. Actually, it's a complete lie that it was not discovered by a bird. It was discovered by a Greek with the name Heron. But it's a good joke, right? Okay, so anyway, what is Heron's formula? So it has to do when I have the case where I have three sides. So let's say I have like a little a, a little b, and a little c. And there's this ingenious formula to calculate the area. I would first define something called the semi-perimeter. And this means exactly what you think it means. It's actually half of the perimeter. So if I was thinking about what has half of the perimeter, I use this little s, and I go through and I would add the sides up and I would divide by 2. So I would go through and compute, say, the semi-perimeter. So I would do S is equal to A plus B plus C divided by 2. This formula comes out of left field a bit, but I think it's so cool because if I think about this 3, 4, 5, right? I'm going to show that it works there. We've already found that, I didn't have the 5 there earlier, but hopefully agree that this third side is 5. We've already talked about how the area of this triangle is 6. Let's verify using this Heron's formula that the area is 6. Actually, I haven't written down Heron's formula yet. I just gave you the semi-perimeter. So I need the semi-perimeter to write down this formula, which is the formula for the area. This is the square root. And this is an S times S minus A times S minus B times S minus C. So this is actually the formula that is Heron's formula. And the S there is this semi-perimeter that I've defined here. Okay, so I want to go through and show that it works for this 3, 4, 5 triangle. So I would first compute the semi-perimeter. So I would add 3, 4, and 5 and then divide by 2. So I've got, what is that? 6. And then I would plug into this formula. So the area is the square root of 6 times 6. And then these sides are A, B, and C, and I can do that in any order. So as long as I've got all the sides subtracted, so like 6 minus 3, let's say 6 minus 4, 6 minus 5. One factor for each one of the sides. Okay, and then you could just punch that in the calculator if you want. Or on this one, I could actually compute it by hand. So this is the area, is the square root of, say, 6 times 3 times 2 times 1. 6 times 6. Square root of 36 altogether is 6. And if you're going to punch it in the calculator, just be careful. I would do square root of, and then 6 times 6 minus 3, 6 minus 4, 6 minus 5, like this. And that's Heron's, sorry, I didn't get all of that in there, did it? So it's like this. Let's scroll over a little bit. So that's Heron's area formula for a triangle. Okay, so, and I could use that with any, so I can use that, the idea is, with any triangle, maybe even one where, it's not a right triangle, it's just some random triangle with 3 sides. Maybe like 2, 3, 4. if I really cared about what is the area of that, I can compute it. So 2 plus 3 plus 4, divide that by 2. That's 4.5. And then my area here would just be the square root of 4.5 semi-perimeter, 4.5 minus, say, 3, 4.5, say, minus 2, 4.5 minus 4. And I would just punch that in on the calculator. I'm going to do that and verify what we get for this area. Like 2.9, and let's say we're working with feet. Approximately 2.9 feet squared. Okay, so sorry, that's good for the week. You're going to have a test. I think I'm going to make that due later that week of working ahead here. It's May 5th right now, but see May 11th, and then you got, I think it's the 15th. I would like it to be due the 15th. I might make it a few days after that for that test, so I can get that test in, and that will be good. That will be just on chapter 4 and 5. And then kind of depending on how you do on that one, I may or may not also have one on chapter 6 and 7, kind of that very last week, but I'm just kind of going to see how you do on that one and see if you want another one. Okay, I will see you